Okay, the purpose of this video, or the objective of this video, is to learn how to simplify surds. And surds, another name or word for surds is, you might see it written as numbers written with the radical sign or the square root sign. Maybe simplifying radicals might be, sometimes the square root sign is called a radical sign. So, but we'll call them surds. And so, in order to, there is a method that would be the most accurate way to re-represent these numbers, kind of like simplifying fractions. 2/4 can be written as 1/2, or maybe even a better way to think of it as a mixed number. If you have 7/3, that is the same thing as 2 1/3. When you simplify that, sorry, not mixed number, but turning an improper fraction into a mixed number. So anyway, let's just get started with some examples. Here we have the square root of 50, and what we can do is we can break this up into two other factors, two or more other factors, and what we're trying to get is factors that are perfect square roots. So you should have memorized the square roots up to at least 10 and hopefully up through 20. So we know that 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. So if you look at 50, we got to think what could be a factor of 50 that is also a perfect square root, and that's going to be 25, because 25 is a perfect square root, and so 50 can be re-represented as 25 times 2. And then once we do that, we can then now split this into the square root of 25 times the square root of 2. Okay, and then we know that the square root of 25 is 5, and the square root of 2 is not a perfect square root, so we just have to leave that. So to simplify the square root of 50, we basically will get 5 root 2. 5 root 2. And if you would want to just check and see if that works out, you already have seen these calculator. You can put in the square root of 50 and push and see what that gives you, the decimal. And then usually in order to put these into a calculator, what you need to do is you need to do the square root of 2 first, get what that answer is, and then multiply that times 5. That would be the easiest way, unless you have parentheses or something like that as a button on your calculator. Okay, let's do a few more. The square root of 48, well, let me just do this two ways. First, I think that we can see, obviously, that it's the square root of 4. And if we see, or 4 is a factor of 48, let's put it that way. And then if 4 is a factor of 48, we get the number left over of 12. Well, we can look at this 12 and we can see that actually 12 can also be factored into 4 times 3. So now we can see 4 times 4 times 3. And of course we could look at this 4 and then take the square root of that and make that a 2. Well, let me just write that. We could make that square root of 4 times the square root of 4 times the square root of 3, and then the square root of 4 is 2 times the square root of 4 again is 2, and then we cannot do the square root of 3, so we have 2 times 2 times 3, and this is 4 root 3. That's definitely one way to do it. The other way to do that is to do this. Up here, instead of, if you can see, the square root of 48, the biggest factors that we'll be able to pull out is actually this is 16 times 3. That's what another way to factor that 48, and we know that 16 is a perfect square root. So again, we have square root of 16 times square root of 3, and that also can give us 4 root 3. So that would be the other way of doing that one. Okay, and then last for here, let's do the square root of 45. Well, what perfect square root factors go into 45? And the one that I can think of is 9. 9 times 5 is square root is 45. So if we separate this into square root of 9 times the square root of 5, and the square root of 9 is 3, we get the answer of 3 root 5. So we know this is useful because sometimes are using the Pythagorean theorem, and we need to use a squared plus b squared is c equals c squared. And in order to do that, a lot of times we have to square root the both sides to get rid of the radical sign. So let's do a few of those. Oops. Okay, here we have a triangle, and we're trying to find this side over here, and we know that the formula a squared plus b squared equals c squared, and c always has to be our hypotenuse, so this is going to be c. And we know that it doesn't matter if we call this a and this b, or vice versa. This is we'll just call it 4a and 6rb. So we will plug that in, and we'll have 4 squared plus 6 squared equals c squared, and 4 squared is 16 and c squared is 36, and b 6 squared is 36, and that equals c squared. And so 16 plus 36, I do believe, is 52, and that equals c squared. Now in order to get c by itself, we know that we need to take the square root of both sides, so the square root of c squared just becomes c, and the square root of 52, well, let's see, I think we can factor that. Let's see, well, the only one I can think of is 4 times 13. 4 times 13 is 52. So since 4 is a perfect square root, it does help us a little bit, and so we get the final answer of square root of 4 is 2 root 13 equals c. It's just a little bit more simplified than what it was before. Okay, let's try one more. Okay, okay, here is a rather tricky problem, I guess. Again, we know that the hypotenuse is c. We'll call this one a and this one b again. A squared plus b squared equals c squared. Now, you'll notice we have some crazy radicals in here already, and let's see what we do with those. Well, we just plug that in the same way we always have, and so our a is the square root of 39. That's fine, so we'll just put that in the parentheses in place of a. Plus, now here we have 5, oops, almost made a mistake there. This is the c, so we don't know what b squared is, and the c is 5 root 3 squared. So let's see if we can do this. Well, we know the square root squared just becomes that number again, so this is just going to be an even 39. That gets rid of that really easily. Plus b squared, we don't know what that is yet. And then in order to this one up here, we need to take the 5 and square it, and then we'll take the 3 and square that. If you wanted to do it a little bit the longer way, you could go ahead and say, well, 5 root 3, let's see, that would be kind of working backwards here, right? Square root of 25 times the square root of 3. Some of you guys can follow along with that. And then square root of 75. That'd be another way to think of this. But let's go ahead and just solve it straight here. So we'll do 5 we'll take this 5 squared and we'll get that to be 25. And then this square root of 3 squared, well, that will just become times 3, and then 25 times 3 is 75, so you can do it that way. And then we'll just solve like we do these problems all the time. We'll do the inverse operation. We'll subtract 39 from both sides. That gives us a b squared equals, and let's see, 75 minus 39 is 36. Okay, and then if we square root both sides, we get b equals 6. That would be our missing side. Okay, so anyway, I hope you found this video helpful, and we'll be working more with these in class. See you later.